All right, so as advertised, we're going to transition from biology to meteorology for the next 20 minutes. And to set the stage, I'm showing here some photos of weather challenges that we faced around here, from too much water and rain and then not enough. And the winter that was not last year all over the place in the upper Midwest. And in Wisconsin, we had our first documented tornadoes during the month of February. Early February, no less. It was really, really crazy. Huh? Oh, sure. Let's see. Everybody's needing help with this.
That's okay.
Okay, we're trying to keep it there.
Yeah,
All right,
yeah.
thanks. So I am from Wisconsin, but until a year ago, I lived in Beloit. I was a 5-minute walk from the border. So I am capable of speaking both dialects, and I'm going to try to be fair to both states, as most of the Fox River is in Illinois after all. But I'm going to try to cover both states. There may be a bit of a Wisconsin bias here, and that's why. Now, kind of give the big picture. I think that a lot of us feel like we're seeing wackier weather and more erratic weather patterns of late. And one of the things our state climatology office is trying to do is to see whether that's true or whether it's just perception. So we put together this, it's called the Extreme Weather Index. The title got chopped off here. Trust me, that's the name of it. And what it's showing is the trend in extreme weather overall, that being departures from normal for temperature and precipitation over the annual period starting in 1895 and going through last year. You don't need to know all the nuts and bolts of it, but here's how it looks when we break it down across the 9 climate divisions in Wisconsin. Everywhere is showing an increase, but it does depend where you are. And the other thing to note here in this location is notice that the biggest increases, over 30%, are happening in southern Wisconsin, including the southeast where we are today. The biggest increase or the peak of this extreme weather index was during the 2010s. That was Wisconsin's wettest decade on record. But the reason for this increase is not just, have both of them here, is not just precipitation, but also temperature. So what I'm showing here are the changes in temperature in winter and summer this century, so since 2000, relative to the early 20th century reference period. The warm colors indicate a warming climate. The green indicates a wetter climate. So what you can see is that almost the whole country is seeing a warmer climate over time, and especially in our area. If you find Lake Michigan and where we are, the upper Midwest has been especially on a warming trend in winter, less so in summer. We're not warming as much in summer, but it's still positive in our area. And then when it comes to precipitation, both seasons are really similar here. You see winter, this is the 15% increase in winter precipitation in this region, and then summer similarly. So precipitation, it does depend where you are in the country as to which sign, how things are changing. But clearly around here in the Fox River Basin, we're definitely seeing a pronounced increase in precipitation. Now, it's not just the total accumulated precipitation that I'm showing there by season. It also makes a huge difference how quickly it falls. What we're seeing across the country and in much of the world is that when we are getting rainfall, it's coming in heavier doses. So this is showing the trend in extreme rainfall days going back to the 1950s. And by extreme, this is defined as the wettest 1% of all days in a given year. So you take all the days when we had precipitation, lop off the weakest 99% of those, and you're left with the real gully washers. And so the question is, are those super wet days becoming even wetter over time? And the answer is yes, they are. And it all over the country, we're seeing an increase. The blues indicate a percentage increase, 45% here in the upper Midwest, and even more if you're in the Northeast. And we'll go into the consequences or the causes of why we're seeing this upward trend in heavy rainfall. But zooming in a bit and looking more closely near where we are today, so this is a trend for Wisconsin. This is showing the number of 100-year daily rainfalls that occurred during the 20-teens decade. So that means that these are rainfalls that are so intense, we expect them to only happen on average once per century. But in that super wet decade of the 20-teens, we had 21 of these across the state, all over the place, north, south, east, west, including the southeast. We had 3 of these, over 6 inches of rainfall in one day. And the one that really takes the cake here, Western Dane County, nearly a foot of rain fell in August of 2018. It's just absurd. It's almost like a tropical storm, but that's what happened. And it's those kind of rainfalls that cause water levels to rise really quickly, runoff, erosion, all the things that we're concerned about. So that's the way things have looked up to now, but what about the future? Where are we likely to head? And what I showed before about a warmer and wetter climate definitely holds based on our forecast, our climate model projections. This is showing the projected change in annual precipitation for a 2 degrees Celsius global warming. So we've already warmed by more than 1 degree Celsius since the pre-industrial period. When we reach 2 degrees of warming, which is almost inevitable at this point unless something drastically changes, what this depiction is showing is that this is how the rainfall or precipitation patterns will change in the United States relative to the earlier periods in the 19th or the early 20th century. So intuitively, green means wetter, and the darker the green, the wetter or the bigger the increase. You can't see it got cut off at the bottom here, but in our area in the darker green, that's about up to a 10% increase in annual precipitation. And the hatching means that that's where the various climate model projections are in good agreement with each other. So we have high levels of confidence, whereas other places like the green in Texas, not as much confidence, not as much model agreement. So keep that in mind for the future, that it does look like we'll be getting wetter. But that's the annual. What about by season? That can make a huge difference. What I'm showing here are the changes in runoff. So this isn't just precipitation, but this is arguably more important if you're worried about water quality in a river or a lake. And what this is showing, if you look at the top here, for a future climate scenario where there's a large amount of climate change is on top, and then an even larger climate change, a more pessimistic scenario at the bottom. And the runoff change in green means that we're likely to have more runoff annually. So that's the left-hand column. So pretty much wherever you are, we're expecting to see more runoff on average. But then it makes a big difference as to the season. So that's what's shown here for winter, spring, summer, and fall. And the darker the green, the more the runoff. And what catches your eye is winter in particular. Look at how green this is. Pretty much the farther north you go, the more runoff we're expecting. That's because we're likely to get more rain than snow in a warmer climate in the future, and also probably more intra-seasonal melt-off events, more so than we used to when the snowpack would build up and then have a big spring flush. But spring too, we're expecting to see an increase in runoff as well, especially here in northeastern Illinois, southeast Wisconsin. Fall, also an increase, but it's pretty weak. And then summer is a mixed bag. It's really kind of, not a huge amount of change. Climate models don't actually agree very well on how summer rainfall will change in the future. So it's not surprising that there's no distinct signal in terms of the summer runoff pattern. But that winter and spring situation, I think, is worth underscoring because those seasons are especially important for runoff for a lot of reasons. One is that that's when we have snow melt, and that can enhance whatever rain on snow occurs. We also have frozen ground during much of winter, really deep frost depths this year because we didn't have a whole lot of snowpack to keep the soils warmer. A lot of places there's manure on fields that time of year, so that degrades the water quality if there is runoff. And then, of course, as we get into the spring planting season, we get those wet soils. So a lot of reasons why this projected increase in runoff during winter and spring has practical importance. Now, what about extreme rainfall? So again, I want to go back to that example. It's not just the average or the total rainfall or snowfall that matters, but this is showing the projected change in extreme rainfall. Again, those heaviest 1% of all days, and as before, based on a 2-degree global warming scenario. So when we reach that point, this is how the map looks. Everything almost everywhere becomes greener, meaning that when we do get heavy rainfall, it's likely to be even heavier in the future. You can almost see the numbers here up to 50% in the darker colors. In our area, maybe 20 or 30% increase. And remember, that's a 20 to 30% increase on top of an already big number. And so that can have some real pragmatic implications. Now, the reason for this increase in heavy rainfalls that we've already seen and we're expecting for the future has to do with the water cycle. So if you think back to you had a high school geography class or an earth system class in college, you probably covered the water cycle, evaporation from land and water, transpiration from forests and crops and so on. That eventually leads to precipitation, and then that precipitation runs off onto land, into streams, into the Fox River, and into lakes, and so on. What happens in a warming scenario is that this cycle continues, but it becomes stronger, and every facet of it becomes stronger. Warmer soils, warmer water bodies lead to more evaporation. And then that eventually can lead to more and heavier precipitation, more intense precipitation. And then, of course, that precipitation has to go somewhere. And so we get more pronounced runoff. And we can even quantify how much more precipitation or water vapor is in the atmosphere. You're going to have to trust me on this because it got cut off. But a warmer atmosphere, this is just basic physics, a warmer atmosphere can hold more water vapor. And the amount is that for every 1 degree Celsius increase in air temperature, or 1.8 Fahrenheit increase, the atmosphere can hold 7% more water vapor. And so that means that when conditions are right for a heavy rainfall, we get a slow-moving thunderstorm, for example, that there's just a lot more precipitation to wring out, and we can get these heavier totals. And to illustrate this concept, there's been a recent illustration that I think is a nice one, a nice analogy by a fellow climatologist named Daniel Swain out at UCLA. He's used the example of a sponge, thinking about the atmosphere as acting like a sponge, the way it sucks up evaporation from the soils and water from the ground, and then produces precipitation. So let's think of a past climate, say a cooler climate than today, maybe the climate of 50 or 100 years ago, the atmosphere acting like a sponge, evaporation occurs, precipitation ensues, and let's just say that there's 3 units of evaporation that this sponge can hold in the past, and then 3 units of precipitation that it can excrete once conditions are favorable. In the future, or even up to now, in the warming climate compared to that reference past, the same process occurs, except now, instead of just 3 units of evaporation that the sponge can absorb, it can absorb 4 units. And that means, of course, that if the sponge is wetter, and it can squeeze out more, say, 4 units of precipitation to boot. And as a result, we can expect greater precipitation variability because there's, it's more effective at sucking up that moisture in some places, drying the soils, and more effective at dumping it out other places, leading to floods. And we've seen this firsthand in a big way in Wisconsin. I'm not sure how much the statistics show this for Illinois, but our office has put this together for what I call ping pong, precipitation ping pong in Wisconsin, going from too wet to too dry. On the left is 2023, on the right is 2024, showing each month's departure from normal. So green months are wet, brown months are dry. The beginning of 2023, we had the wettest start ever to a year. Then we flipped to a major drought. And then we had a wet October, 8th driest November, and you see more of the same in 2024. We had that wettest March through August on record, and then we had an ensuing major drought. And then just to tease us, November was really wet, and we just had our 3rd driest January on record. So it's all over the place. And this is an example from my colleague Trent Ford, the Illinois State Climatologist, showing what happened in 2023 in Illinois. A flash drought, meaning one that comes on really suddenly. I think this is a picture from his house. And in middle of May of 2023, this is how the drought monitor depicted Illinois. The yellow colors mean that it's just abnormally dry, not even really a drought. 6 weeks later, the whole state was in drought, a lot of it in major or extreme drought. So an extremely quick transition to drought conditions. Now, what can we do about it? I'm involved with this Wisconsin Initiative on Climate Change Impacts, or WICCI. We've been around for almost 20 years now as a partnership between the DNR and University of Wisconsin-Madison. And what we're trying to do is to find solutions to climate change impacts. So things like this flip-flop of precipitation or heavier rainfalls. So our mission here is to generate and share information to foster solutions. We sit at the interface between climate science and climate adaptation. Our work is done by our 14 volunteer working groups that cover various aspects of climate change. They're shown here for the categories of air, water, land, and people. Highlighted a few of relevance today: infrastructure, agriculture, water resources, and climate. We produced our big assessment report at the beginning of 2022, and we have on schedule for the next year at some point have an update on that. So be on the lookout for that report coming in 2026. Okay, so covered a fair amount here in a short amount of time, but the key takeaways as I see them: one is that extreme weather overall has been increasing in Illinois, in Wisconsin, especially in the South. We've also done this analysis, but at not as fine a scale for other places, and Illinois also shows an increasing trend statewide, as do other states. Warmer and wetter are the key words to describe climate change in Wisconsin and Illinois, and that's both at present and expected in the future. Winter and spring are the 2 seasons that show the clearest sign of becoming wetter, whereas summer is less certain. We're not even completely sure whether summer rainfall will go up or go down. But we are confident that there will be more extreme precipitation when it does fall, and that's been the case up to now, and it's likely to occur in the coming decades. And then finally, we expect to go hand in hand with the heavier precipitation, the greater variability, going from too wet to too dry and back again, often quickly, as we've seen good examples of in the last 2 years. So I will stop here, and if we have any time for questions, happy to take them. Thanks. Is it also windier? It's funny, I just got that question the last time I spoke to a group. The problem is, we would love to know the answer to that. There seems to be some evidence that when we get these really strong winds, like from derechos, these strong straight line winds, that there's been some high profile examples. The problem is, to address this question of long-term trends in winds or wind speed, is that we don't have great data. And one of the reasons is that the way we keep wind data changed in the middle 1990s. So some of the major weather stations at airports changed their sensors. So they changed to a more automated system, which is great for most things, but it's bad if you're trying to keep consistent records. So unfortunately, we don't have a good answer to that very logical and important question. And it looks like we need to stop, it appears. Thank you very much.
Thank you, Steve. Okay,